So before we start studying the actual kind of functions here and what they look like on a graph, we need to go over like exponent rules and some rules for radicals, which some of it might look familiar, probably not what we're doing today, but this stuff you've probably never seen before. It's called the real nth roots of A, which is a very weird way to say we're talking about this symbol. What is that symbol called? I love that you called it a square root. That's actually not its name. It's called a radical. We've called it a square root for forever because that's the normal use of the symbol, but that symbol is called a radical. The reason it's called a radical is because there is a number n that is seated on the little house right there. You see how there's like a ledge on the side of the house? Normally that's a 2, which is why you call it a square root, because 2 is square. But we can take different numbers up there. They're called nth roots. So instead of square root, it could be the cube root, it could be the 4th root, it could be the 5th root, 6th root, whatever number you put up there, that's the root. But the A value we're talking about is just the number here inside. So we're just going to be taking different roots of different numbers. There are 2 scenarios for this to happen. If n, which is the number sitting on the outside of the little ledge, is an even number. What is an example of an even number? 2. What else? Anything multiplied by 2. 2, 4, 6, 8, 10. All of those are even roots or even powers. Then you're going to follow these rules right here. So these are the rules for evens. And if the number sitting on the outside of the little ledge, it's technically called the index, but we're going to call it n. If you have an odd number, which means it's a number like 1, 3, 5, 7, something not divisible by 2, you're going to follow these rules. So there are different rules depending on if that number is an even number or an odd number. If n is even and you are taking the nth root of some number, remember A is on the inside, that is less than 0, aka some negative number. You can't take the nth root, the even root of something that's negative. So you would just stop, you say no real solutions. That's when we would get into our imaginary answers, which we're not doing today. If it's equal exactly to 0, then it's 0, duh, because whatever root of 0 is still 0. And if it's greater than 0, meaning it's some positive number, then you have 2 real roots. Now this is super important that you notice we have added this funky looking symbol in front of it. Does anyone know the name of that funky looking symbol right there? It's named really normally. What does it look like? A positive, negative? What's another way we say that? Not positive, negative, but like addition, subtraction. Whoa, we're dancing around the words I want. It is literally called a plus or a minus. That's the name of that symbol. It is a plus sign and a minus sign, so it's called plus or minus. It means you have 2 solutions. One of them is positive, one of them is negative, but it's the same number for whatever we get when we take that root. When n is an odd number, the rules are a lot easier. When it's odd, there's always going to be one answer. So no matter if it's negative, if it's equal to 0, or if it's positive, there's always just one root when the nth root is negative. Odd. So odd roots are honestly easier because there's only one. A couple more pieces of information. This is like a nice reference sheet for us later once we use it. What exactly is a rational exponent? When we're talking about rational exponents, we're talking about fraction exponents, which are totally allowed to be things. And in fact, I personally like fraction exponents better, but you're allowed to have your own opinion. That's fine too. But if we were writing a fraction exponent and we wanted to rewrite it so that it actually looked like the radical with the symbol, the acronym we're going to use to do this is called numerator behind denominator front. Also known as nobody does fractions, which I disagree. Everybody does fractions. But you can think nobody does fractions. And if you remember that the numerator goes behind, so look, the numerator of the fraction went behind, and the denominator goes in front, and look, this denominator didn't go in front. That's how you change up from fractional exponent mode to radical mode. Numerator behind, denominator front, and it is literally that simple. I think in Algebra 1 you used the phrase top in, bottom out. Same idea. Numerator behind, denominator front. The last rule that we just kind of want to touch on, does anyone remember what happens when you have negative exponents? Are we allowed to have negative exponents in our final answers? No, so we did something with them. And what we do is we just drop that entire thing to the other side of a fraction bar. So instead of this being on top, we go ahead and we take this and we move it to the bottom. That way we get rid of the negative. But notice literally nothing else changed. I just changed the sign of the power. That's one of the fraction or exponent rules that we'll eventually go back over slowly. But now this is a reference sheet for you that's like quicker to look at probably than what we're going to do in our notes today. So keep that on your desk in front of you so that we can have it. But we're going to go to the packet so you can actually, the brochure so you can actually see what we're doing with this information. As a quick review, when the nth root is even is the one that has the rules. There is one real root when the a value is equal to 0. It's 0. The answer is 0. When the nth root is even and there are two real answers when the a value is positive, which means it's greater than 0. But we'll go ahead and write the word positive there because I feel like that's easier to understand. And when the nth root is even, there are no real solutions. That would be what you answer when a is less than 0, aka a negative number. On the other hand, if the n number is odd, no matter what scenario you have for the a value, there is always one real root. So one of the things that's going to be helpful today, because I don't think we necessarily know all of our roots. We might know our square roots, but when we get to cube and fourth roots, I'm assuming that you don't know them because I don't really even have them memorized either. So it's going to be really helpful if we have these calculator steps for finding different roots memorized. So I would put like a little one of these things in there. Let's say that we were trying to find the third root of 8. That's the question. Now we've kind of talked about this one before. But if that root gets higher than 3, there's no shortcut on your calculator. So right now I want you to just do these problems right here. Type in the n to your calculator. The n is this number sitting on the ledge. So everybody type in 3 right now. Because we're going to take the third root of this number. So we type 3. Then we press math. And the option 5. Option 5 is an x root, which means it's going to take whatever you've already typed, we typed 3, and place it as the index on the ledge. Did that happen on your calculators? Great. And then you can type the number in the radical, which is 8. So type 8. And then you press enter, and it should tell you exactly what the cube root of 8 is. What is the cube root of 8? 2. Okay, well, what about the fourth root of 27? Can you give that one to me? So same thing, you start typing with the 4, you go math, you go 5, then type in the number. That's a great question. I did this on purpose. What if it's a decimal? I know that your homework is going to have you round your decimals to 2 decimal points. That's also what I like. So we're going to go ahead and round this to nearest hundredths. Now when you're rounding numbers in math, most likely you're going to change the equal sign to the curvy equal sign. Have you all ever seen that before? It means approximately equal to. It's an indicator that I rounded this number. But if we round that number to 2 decimals, what is the number? which one? 28. Is that correct, everybody? So that's pretty cumbersome. So that is one way we can type these things into the calculator. And that is absolutely fine. In fact, learn that. I personally don't like doing that. So I'm going to teach you an additional way that maybe some teachers don't show you that I like better. This was before there were fancy calculators that could do the index. We couldn't do that in the calculator. So we had to use the fraction exponent version. So if we did these problems again, and I actually want you to write these things down. If we did these problems again, but instead of with the radical, we did numerator behind, denominator front, we would change this problem to 8 raised to the 1/3 power. Wait a second. Where did the 1 come from? Now remember the phrase was numerator behind, denominator front. Do you see an exponent behind here? No, what's the invisible exponent? 1, which is why my numerator became 1. Where did the denominator come from? The front. Yeah, the n. So if we were going to change this one in the same way, how would you write down the fourth root of 27? 27 to what power? 1/4. Yeah, what number's behind it? An invisible 1. What number's in front of it? Okay, I personally like typing these into my calculators this way. Type the number 8, then type the exponent button, and in that exponent, make the fraction 1/3. You can use the fancy fraction or you can use the divide key, it doesn't matter. 8 raised to the 1/3 power should give you the same answer. What does it give you? 2. 27 raised to the 1/4 power, what does that give you? A decimal that we round to 2.28. Either way you do this, if I'm asking you to evaluate a number, 100% fine. I personally like doing it this green way because that's the way I learned. We didn't have fancy calculators that could do the radical sign. And that's easier for me to remember because it's still an exponent. You get to choose what you like. So either way is fine. So let's practice that a little bit. We want to make sure when we're taking the indicated roots of these numbers that we're actually doing it correctly. Because we have to know whether there's 1 or 2 real solutions here. The way that we do that is we go ahead and write it with the n and the a where they're supposed to. That means the n goes on the outside of the little root, the radical, and the a value goes inside. Now, what index do we have here? Is that number that's on the ledge, is it an even or an odd number? This number right here is a odd number. When it's odd, we will literally just have one real root, and it's something that the calculator will find. Period, point blank, the odd ones are the easy ones because you just beep, 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 type it in your calculator. So you can either type it in like this, cube root of -216, or you can type it in the green way like we did earlier, -216 raised to the 1/3 power. I do not care which way you use, whichever way you see fit for you. But when you do that, what does your calculator tell you? -6. And we know we should only get one answer because it's an odd index. So boom, we're done. Okay. If we go to the second one, what's the little number on the outside of the radical going to be? 4. And what's the number inside the radical? Cool. Now this time, our index, which is the number on the outside, is an even number. Even number means we need to think for a second. We have to look at the number inside. What kind of number is it inside? You have 3 options. It can either be 0, a positive number, or a negative number. What kind of number is inside? Positive. When the number inside is positive, you're going to have 2 answers, 2 real roots. This is the one where you're going to have to put the plus or minus symbol. Cool. So we go to our calculator. We type the 4th root of 81 either like that or with the fraction exponent. And our calculator is going to tell us that 81 raised to the 1/4 power is what? 3. But that's going to be wrong. If you answered 3, that is incorrect. Why is that incorrect? Because it's not just 3. Plus or minus. You have to put that symbol for me in front of your answer when it is an even index and a positive a value. Okay. If you need to make a note for yourself about that, maybe circle this a whole bunch of times. Be like, don't forget this. That's going to be huge. If it is even and positive, you have to give me the plus or minus button. Button. I keep saying button. Y'all know what I mean. Okay, let's go to the last one. What is the index for question 3? The little number. 2. What's the number inside the radical? -400. Okay. What kind of index do we have? Is it an even or an odd number? Even. Okay, even is the one I have to think about for a second. What kind of number is inside the square root? Negative. Am I allowed to take an even root of a square number or a negative number? No, which means we're going to say that this has no real roots. And like that's actually That's actually the answer. No real roots. But I want you to see what happens if you forget this. So in your calculator, I want you to do the square root of negative 400, which if you're doing it the exponent way is parentheses negative 400 raised to the 1/2 power. Either way works. What does your calculator tell you when you do that? Square root of negative 400. Error. It's going to say error, and I think it says undefined. Yes. That's your indicator. If you forget this fact and you're like beep, 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 going into your calculator and it says that, that's when you're like, wait a second, no real solutions. I'm not allowed to take an even root of a negative number. Which means if we go back to what we did at the beginning of this page, up here at these random problems I made up, something's wrong with one of the answers we have. Can you figure out what's wrong? Let me give you a hint. Something's wrong in this part, in this fourth root of 27. Is it an even or an odd index? Even. Is that number positive or negative? Positive. When it was even, index with a positive number, what did we have to put in front of the answer? Plus or minus. So slide in a plus or minus right there. We have to include that in our answers when it's an even index with a positive number. That's the plus or minus symbol. Okay, fabulous. On to the inside. So we've taken some nth roots. We found the nth roots. And now we're going to just keep using the different rules to go back and forth from the different, just getting used to the numerator behind, denominator front thing, which we'll go ahead and write down here again. That was numerator behind, denominator front. That's the idea for these rules. Numerator behind, denominator front. The questions here say to change each expression to get rid of the radical sign. So we want to write it in fraction exponent, which means we just need to know the numerator and the denominator. Okay. For this one, the base stays the same. So the a value is never going to change. I'm going to leave this as a. But how would you rewrite this one so it had a fraction exponent? If the numerator is behind, what number is behind? What number is behind? 3. That's my numerator number. If the denominator number is in front, what number is secretly in front? Ooh, I'm glad you said that because that's a common misconception. Before today, what did you call this symbol? A what root? A square root? So what's the invisible number for a square root? 2. That's the only time your invisible number is not 1, is on a square root. So this should be a to the 3/2. Now, I want to be picky about this for a second because you're going to confuse yourself if you write the number like this. Why is that confusing? Does that look like an exponent? So make sure your exponent is truly in exponent mode. So make sure it's bloop up there in exponent mode. If that means that it's like really high up there, that's fine. It needs to look like an exponent though. Don't make it look like a coefficient sitting next to that number. It's very confusing. That's it. That's all we're doing. Just changing it to fraction exponent form. So if we go to question 5, how would you rewrite that one? A with an exponent of the numerator is behind. So what number is behind? 2. What number is in front? 3. So this is a to the 2/3 power. Numerator is behind. So numerator came from behind. Denominator came from front.
So if the invisible number is in the front, it's 2, but if it's behind, it's 1?
Yes. Did y'all hear what she just said? If the invisible number is in front, it's 2. If the invisible number is behind, it's 1. So your invisible numbers are not the same on these problems because the roots, the radicals, are the only time the invisible number is 2. Okay, let's do this one. The a value does not change. Whatever's inside the radical, don't change it. What should I put on top of this fraction? 1. What should I put on the bottom? Ooh, so here's another good point. Index will never be negative. So this negative is big. If it were trying to be small, it'd be floating up here. This is just sitting in front of the entire problem here. So we are just going to end our problem with a giant negative sign in front of it, since it started with a giant negative sign in front of it. That negative being in front of the entire thing means the entire thing is negative. Alternatively, look at number 7. There will be a negative sign in this one, but it's not going to go in front. Where will the negative sign go? I think I gave you too far of a jump here. Let's first start just by changing the denominator to fractional exponent mode. The base is going to be a. What's going to be the numerator? That'll be the denominator. 1. The invisible number 1 will be the numerator. Since there's a 1 back here, it's invisible. Here's what the final answer should actually look like. Why? Why did the large fraction go away?
Because you divided with the 1 there.
Good idea, not quite. I'm going to scroll up here for a second. Look at this rule, the second rule right here. What does it say to do with negative exponents? Bring them down. So if I had something already down, how do I bring it up? If it was negative, we move it down. So if it's down, what do we do to move it up?
Make it positive.
Well, it's already positive here. If I wanted it out of the denominator, I'd have to make it negative to put it in the numerator, which feels weird because all this time I've been telling you don't have negative exponents. But this is way easier to type in a calculator than this would be. So you get to use that rule backwards if it makes your life easier, which seems weird.
Do you multiply?
You literally just flip the symbol. This is the exact same thing as this, except that now it's negative. There's no multiplying. So the difference in these two problems is that the first one, the negative sign affected the whole thing. And in the second problem, the negative sign came from the fact that this was in the denominator, so now it became a negative. Do we see the difference? It's confusing because for all this time I've been telling you no negatives for exponents, and here's the one time you're allowed to. Feels weird. Honestly, for me, if you stop here and put a box around your final answer, I would probably give you credit because you followed my normal rules. But you are also allowed to do it this way. Math. Okay. Let's keep going. We're going to practice simplifying just regular numbers. Do you notice that there are no letters here? Which means when we finish this, we should get a decimal or a whole number. Because there are no letters, we can actually get an answer. We're going to rewrite them into radical form just for good practice, and then we will simplify. If we wanted to take 16 to the 3/2 power, first of all, I'm going to set it up by doing this. I put my radical and my 16, and then I just have to put the numbers where they go. But the numerator goes behind, and the denominator goes in front. So what number should I write in front on this little ledge? 2. And what number should I put behind? 3. Now, because of the way that square roots are, you actually can simplify this to just the square root of 16 to the 3rd. Remember, this can be invisible. You can show it if you would like to, but it's allowed to be invisible because it's the invisible number. And that's something we can type in our calculator. Please either type what I've boxed in black or what I've boxed in green, because both are fine to type into a calculator. Whichever one you like typing in more, with the radical or just with the fractional exponent. What'd you get? 64 is correct. Now we do need to add something to 64. What do we need to add in the very front of 64? Why are we adding plus or minus? Because the index is even and that's a positive number. So anytime your index or the little number on the ledge is even and you're taking a positive number, which is a lot of the times, you need to put the plus or minus in front of it. Okay, let's work on number 9. The first thing I see is that this number is negative. Yikes. I want to get rid of the negative exponent. So I take the whole thing to the denominator. And all I change is the fact that that 3/5 power is now positive. Did we follow that direction? I know I confused you earlier when we went the opposite direction, but does that make sense to get rid of it? Okay. Then we do numerator behind, denominator front. So what number should go on the index, on the ledge? 5. And what number should go at the back? Numerator behind, denominator front. So the numerator number goes behind. Okay, cool. So we can throw that into a calculator. You can, again, either type all of this with the fraction, with the 5, with the root, with the 32 to the 3, or if you find it easier to use the fractional exponent version, you can just put that in a calculator. Either way, it should be able to change that one to a fraction. We should have gotten 1/8. And I believe on decimal version, that's 0.125. So if you got that, you got 1/8. Do we need the plus or minus on this one?
No.
Why not? It's odd. The index is odd, which means we do not need the plus or minus. Odds are the easy ones. You just do the problem. So the reason that we go over doing all of this is because once we get into solving these cubic and higher order polynomials, specifically the way we're going to be solving them with rationals, is it's going to help us solve equations as long as we remember the rules. So we're going to go back and we're going to find the real solutions of the equations, rounding to 2 decimals when appropriate. The steps that we're going to follow for all of these are going to be to isolate the parentheses or the x with a power, whatever the power is. Then we're going to take the nth root of both sides. This is where it becomes important to remember if you need that plus or minus, because sometimes we're going to need it. Not all of them. We're going to need the third step. We're going to keep solving if needed. This is going back to inverse operations, adding and subtracting, multiplying, dividing, that whole business. So if we were trying to isolate just the x with the cube, what would I need to do to both sides to get that all the way by itself? Say again? Do what to the other side? Because yes, we're going to do something on both sides, but what specifically are we doing? Divide by? We're going to divide by 6 on both sides. Okay, that means these 6's go away. I'm left with x cubed equal to -6 divided by 6 is -1.
So we just canceling out the left side?
Yeah, because we just want the x with the cube or whatever the power is, the parentheses with the power, thing with the power essentially by itself. Because then we want to get rid of the power. The inverse operation of doing something to the third power is that same root, which means I'm going to take the cube root of both sides. Just like the opposite of multiplication was division, which is what we did in step 1, the opposite of cubing is cube rooting. These numbers have to match. Do you see that? If that happens, then they essentially cancel each other out, and all we're left with is x. Woo, x is by itself. We just have to remember what the cube root of -1 is. First of all, am I going to need the plus or minus? If this is a 3, am I going to need plus or minus?
No.
No. Okay. So this is a question for our calculator. So either by typing the cube root of -1 or by typing -1 to the 1/3 power, which is the fractional exponent version of this, what is the value of x? It should be negative. And voila, we've solved for x. So it feels like what we've been doing since like 8th grade with solving, but it's actually a little bit more complicated because we're introducing the roots, the nth roots. But it's literally just match up the root that you're taking with the power. Don't overthink that. Those numbers have to match and you're good to go. Can I have you try a random bonus that you're going to write in right here? You have all the space, probably. Can you try doing the problem 3x to the 4th equal to 48? I want you to solve for x, so this is a bonus question. Find some space on there, you should be able to do it. I might be cutting off your thinking. Is the first thing you chose to do divide by 3? Fabulous. Once we divide by 3, we have x to the 4th equal to 16. What root am I going to take on both sides? The 4th root, because I want the root and the power of x to match up. The 4th root of x to the 4th cancels each other out. We're just left with x, and then all we need is the 4th root of 16. That's a question for your calculator. What is the 4th root of 16?
16. That's what I thought.
Uh-oh. So remember, it can be 4th root of 16 or 16 to the 1/4 power, because 1 was behind, 4 was in front. We should get 2, but if you only answer that, it's wrong. Why?
It's a positive. Oh, so even.
We need the plus or minus. Why do we need the plus or minus again? What's even?
The
Index, the little number. If the root number, called the index, is even, you need the plus or minus. Unless that number is negative, in which case there's no answer, but your calculator would tell you that. Okay, so we see how this is now adding another layer for what we can solve for. That's fabulous. We're going to do a couple more examples, and then we'll get to the hallway. Good morning. Let's go to number 11. Now this one is just tiny bit more complicated. Do you see the thing with the, I'm using air quotes here, the thing with the power is this whole parentheses. Do y'all see that? That's what I want to isolate first. The thing with the power. Which means, what am I going to divide both sides by? What is not the thing with the power that's over here? 2. I'm still going to divide both sides by 2. It gets rid of this 2 in front. And then I have the thing with the power, x plus 5 to the 4th, isolated. 162 divided by 2 is 81. I know this looks complicated because there's a whole bunch of stuff in here. Don't worry. The thing with the power is isolated. Same way we did when it was a plain x. To get rid of that 4th power, you take the 4th root. The 4s will cancel each other out here so that I'm left with whatever was inside, which was x plus 5, equal to the 4th root of 81. Now the 4th root of 81, you can type in your calculator like that, or you can type it in 81 to the 1/4 power. Either way, what do you get? 3. But if you stop right there, something's wrong. Y'all noticed this in the last problem. What do I have to include there? The plus or minus symbol. Yeah, that index is even. And I had a positive number, so I need the plus or minus. Ooh, okay, so not as cute. Plus, I'm not done, because x is not by itself. How do you get this plus 5 to go away? Subtract 5 on both sides. Now this feels weird, and here's how you're going to do this part. You cancel out the 5s, obviously, and you're left with x equal to, and you're going to write both of those things next to each other. -5 plus or minus 3. I know those are plain just numbers, and you can combine them, but we need to do it in 2 parts, because we need to do the plus version, and we need to do the minus version. So if I scoot over and I do both of these, I would do x equal to -5 plus 3 and x equal to -5 minus 3. I have to do both. But like, that's just combining like terms. That's arithmetic. We're studying for our SATs, so we do that in our head. -5 plus 3 is -2. And -5 minus 3 is -8. So there are our two answers. We have two answers because we put that plus or minus symbol. So when you put plus or minus, you should get two answers. Last basic practice problem here. Y'all are going to help lead me through it. What should I do first to isolate this thing with a power? So we would divide if that number is directly in front of it. Right now, 32 is being subtracted from it. So what's the opposite of subtracting? Adding. Again, we would have divided if that -32 was like attached to the x to the 5th. Plus 32 on both sides. I'm going to end up with x to the 5th equal to -32, which is 64 plus 32. Okay, what root am I taking on both sides to get the x by itself? 2? 5, okay. We're taking the 5th root of both sides. When I do this 5th root, do I need the plus or minus? No, because it's not an even. So that means I can just throw that in a calculator. The 5th root of -32 or -32 to the 1/5 power, whichever way you like writing it better or typing it. -2. And since it's odd, I don't need positive or negative. Boom. We have allowed ourselves now to solve so many more quadratic or polynomial functions, now knowing how to undo a cube root or a 4th root or a 5th root. This is huge. An application of this, which is pretty cool, the volume of a cube is 1,728 cubic inches. What are the dimensions of the cube? Okay, first of all, and you're going to learn this when you take geometry if you haven't yet, anytime you're given a scenario like this, you're going to want to draw a picture. So here's my cube. The little tick marks on this cube are indicating that all of these side lengths are the same. Again, something you might learn in geometry a little bit more. But there's my cube. It's not the greatest. When you have a cube, what's the like special properties of a cube? What do you know about it?
Equal sizes equals equal
To each other, right? Yeah, all of the sides are equal to each other. So if we let them all be some variable x, I don't know what it is, but our length, our width, and our height are all the same value, x. When we find volume, again, this is a geometry fact. Volume is length times width times height. It's the dimensions of the cube. But if we were finding this volume, our length is x, our width is x, and our height is x. Well, what's x times x times x? Don't say 3x. Cubed. So really, the equation for volume of this cube is the side length cubed. What does the problem tell me the volume of the cube is? 1,728 cubic inches. So that's the volume. So that must be equal to x to the 3rd power, because that's the volume. Well, if I wanted to find out what just one of those x's was, how do I undo this again? What root do I take? The 3rd root, yeah. So we're going to take the 3rd root of both sides. Do I need plus or minus? No, because it's an odd number. The 3's cancel each other out. This will just be x. And we can do the cube root of 1728 in our calculator. It'll give you 12. So there is application, especially to geometry, of doing this when your dimensions of a shape like a cube are all the same. But until today, we wouldn't have known how to figure out what each of the dimensions were because we didn't know the undo of a cube. It's a cube root.